No ifs, elses, or switches about it. Hey there, everybody. It's nice to see you. My name is Noah, and welcome to Arcade Games. Today, we deepen our understanding of C# by talking about condition and decision statements. Thus far, you've learned about basic data handling using variables, and you've learned how methods are utilized to perform sets of instructions in your code. If you've taken a moment to consider what types of instructions you may write, however, you no doubt have come to realize that some should only be performed when certain conditions are true. That's where today's lesson will come in handy. We're going to do things a little bit different today. We're going to explain each of the concepts up front before putting them into practice. You may remember seeing statements such as these in elementary math classes. Equal to, is not equal to, greater than, less than, greater than or equal to, and less than or equal to. In programming, these are called condition statements, and they're very valuable because they evaluate to either true or false. Take, for example, this statement. This statement says 5 is greater than 2 plus 1. That is a true statement, and so in programming, evaluates to true. This statement says 12 minus 3 is less than or equal to 2 times 3. That is a false statement since 9 is greater than 6, and therefore the statement evaluates to false. Cool. Easy enough concept to understand. But how do you type these symbols? Well, you can't. Basic is equal to is already used as the assignment operator as you learned in our lesson on variables. Everything else, other than greater than and less than, require a little weirdness. So we'll have to use slightly different symbols that are more keyboard friendly. In order to check equality in C#, you'll use two equal signs. This is the same as saying A is equal to B. In order to say not equal to, you'll type an exclamation point followed by the equal sign. Side note, the exclamation point is also known as the logical not operator, and you'll see it pop up in more places than just this one. In order to say greater than or less than, you can just use those keys on your keyboard. Greater than or equal to is the greater than symbol immediately followed by the equal sign. And finally, less than or equal to is the less than symbol immediately followed by the equal sign. In isolation, condition statements are easy enough to understand. Where they get a little more confusing is when you need to evaluate multiple statements at once. Think about the FPS reloading example we discussed in the last lesson. If the player presses the reload button, and their current clip has bullets missing, and they have bullets in reserve, then the reload should occur. That's testing three conditions at once. The button press would be a simple boolean as discussed in the first lesson, but the other two conditions would be the condition statements that we just discussed. To join conditions together in the way I just mentioned, you'll type ampersand, ampersand. This is how you say condition A and condition B. There is a bit more depth to this concept, however. When you combine conditions using AND, you're essentially creating one supercondition that can evaluate to either true or false. In order to get the overall condition to evaluate to true, all combined conditions must evaluate to true. Therefore, 10 is less than 20 and 3 is greater than 1 would evaluate to true, because both of those conditions by themselves are true. 6 is greater than 4 and 12 is greater than 15 would evaluate to false, because 12 is greater than 15 is false. Taking it out one step further, 7 is greater than 6, and 2 is equal to 3 minus 1, and 9 is greater than 10 would also evaluate to false. Even though the first two conditions are true, the last one is not, so the entirety of the condition is false. And isn't the only way you may want to combine conditions, however. What if you want to check if one or more conditions are true or another one is? For instance, you may have locked doors in a dungeon in your game. They can be unlocked by touching them when you have keys available or if you're playing as a thief. In that case, you'd want to check if has key or character is thief, unlock door. To say or in a string of conditions, you'll type two vertical pipes right next to each other. Unlike the AND logical operator, where the overall condition will only evaluate to true if all conditions are true, the OR logical operator will evaluate to true if any of the conditions are true. So if we have 5 minus 2 is equal to 1, or 4 is greater than 3, we would get true as the evaluation. The first condition is false, but the second one is true. Therefore, the entirety of this expression is true. If we have 10 is less than 2, or 3 plus 2 is greater than 4, or 100 is equal to 0, we would also get true, because the second condition is true, even though the other two are false. Now that you generally know how condition statements work, it's time to learn one of the ways you can put them into action with the first decision statement we're going to talk about in this lesson, the if statement. The way the if statement works is a condition or set of conditions are evaluated, and if the result is true, some block of code will execute. The way an if statement is typed is shown here. First, you type the word if, followed by your condition or conditions in the parentheses. If whatever is in the parentheses evaluates to true, the code block will execute. If whatever is in the parentheses evaluates to be false, the code block will not execute. It's basically like the if statement is skipped over. The if statement also has two closely related statements, the else statement and the else if statement. The else statement is simply another block of code after an if statement, or else if, as you'll see in a moment, that will execute if the condition or conditions in the if statement evaluate to be false. It does not take any conditions, as the conditions after the if determine whether or not the else block executes. Please note that this is not the same as simply placing code after an if statement. If else is an either or type of statement. Putting code after an if statement that evaluates to true will still execute the code after the if statement. With an if else statement, the else only executes if the if statement condition is false. Then there's the else if statement. The way this statement works is that it's evaluated after an if statement whenever that if statement's condition evaluates to false. Therefore, if the original if condition is true, the else if condition doesn't even bother to check itself. However, if the original if condition is false, the else if condition is checked. If that else if condition is then true, the else if code block executes. If the else if condition is false, just like the if statement, it will not execute. You can combine all three of these statement types. The rules to do so are that the if statement must be first. You can have as many else ifs in the middle as you want. Just keep in mind that they cascade downward, so if an else if higher up in the list executes, none of the other else ifs will be evaluated at all. And then, finally, you can have an else statement at the very end. The else statement will execute if the if condition and all else if conditions in the middle evaluate to be false. Back in our good old player character script, let's put some of these concepts to work. I've made some updates based on last week's homework. Our health variable is class level. We have a damage method that takes an integer and reduces that health variable's value when called. And we have a heal method that takes an integer and increases the health variable's value when called. Both methods have print statements, so we know which one we're in when we run a scene. I've removed the damage and heal amount variables from the _ready method because we're going to start plugging in random values for testing. This time, let's work on the heal method. It's great to increase the player's health, but if we don't put a limit on how high our player's health can get, we could, theoretically, just keep healing them until they have over 2 billion health, and that's definitely not intended. What I'd like you to do now is take a moment, pause the video, and work through how we can prevent this from happening. You have all of the knowledge you need to do this in a correct and efficient way. Think about what you've learned about variables, scope, condition statements, and decision statements. Once you've thought about things, come back for the answer. The way to make sure our character doesn't heal above a certain amount is to add another class level variable which stores our maximum health. Then in the heal method, we'll check to see if the heal puts our health variable above that maximum health. If it does, we'll set the health variable to our maximum health variable. So first, let's declare a member variable called max health. We'll set it to 20. Our player character shouldn't heal above this amount. So right underneath our health variable declaration, let's type private int max health equals 20. Next, in our heal method, just below where the health is added, we'll check the value of our health variable. If it's above max health after being incremented, we'll set the health variable to max health. So down in our heal method, underneath health equals health plus heal amount, we'll type if health is greater than max health, and then we'll make our code block, and we'll say health is equal to max health. Since we only have one statement here, we're allowed to get rid of the curly braces in the if statement if we want to. This also applies to else if and else statements. I'm going to do that because I like to keep my code as succinct as possible. However, I will note that the Microsoft conventions is to always keep the curly braces with if, and else statements. So do what you feel is best. Finally, we're going to check our results. In the _ready method, let's add a print statement to check our health before any sort of heals. So we'll do gd.print, and then we'll type the word health with a colon. And if you remember, this is string concatenation. So we'll get a nice little label on our health variable output there. Next, we're going to heal the player. Let's do a very large amount, like 100. To do that, we do our method call with 100 passed in as the argument. Now we'll make another print statement to check the value of health after this heal call. Remember, health is a class level variable now, so we don't have to worry about it being out of scope and it's not being passed by value, so its value should change. And we're just going to type exactly what we have above our heal statement. All right. Now, save your script, go back to Godot, and run the scene. In the output console, you can see we're in _ready. Next, our initial health value prints out and is 10, exactly as it should be. We call the heal method, which we know we passed 100 into, but when it gets back to the _ready method and is reprinted, it's 20. Our if statement worked as expected. Okay, now let's say we want to play a specific animation if the player heals, but then a different animation if they heal up to full health. Since we're not doing animation calls yet, we'll just print off a message to sort of simulate this. If we do a heal and the player's health is not full, let's print off regular heal animation as a message. And if we do a heal and it fills the player's health, we'll print full health animation. Take a minute to figure out how we do this. Again, you already have the knowledge as long as you've been following along. Once you think you've got it, unpause the video and I'll show you the answer. We're already checking when the player hits max health, so let's start there. We want to perform 2 actions when this happens now, so we're going to have to add the curly braces back. We have ourselves a genuine code block instead of a single statement. So let's cut and paste that, shore that up there. Next, we'll add our print statement just below resetting the health variable to max health. So we'll do gd.print full health animation. Now, there is an issue with our logic here. Can you see what it is? This if statement only executes if health is above max health, but we want the animation to play when health is at max health. There are 2 solutions here. We can either add another if statement below this one, as that would give our health variable a chance to set itself where it needs to be, or we can just add an equal sign to the greater than symbol to make it greater than or equal to. Let's do that. It's a bit more elegant, and it's a lot easier to read than having to deal with code that has multiple if blocks. Next, we'll add an else statement. and print off normal heal animation. Again, since we're only doing one thing after the else, we can remove the curly braces if we like. I'm going to do that. Now, up in underscore ready, let's remove everything but the initial print statement that's telling us that we're in the ready method. Now, we're going to heal the player for 2. This will put the character's health at 12, calling the regular heal animation. Next, we'll heal the character for 50. This will max out the player's health. Therefore, it should call our max health animation. Now, save your script, return to Godot, and run the scene. Awesome. We heal the player, and they're below max health. We get the regular heal animation. We heal them, and they hit max health. We get that full health animation. That's if and else statements at work. Now let's say we want to play a specific animation when the player is damaged, and the animation that plays is dependent on the damage type. So if we get hit by a fireball, it'll play a burning animation. If we get hit by electricity, a shock animation, and so on and so forth. We need to account for 4 types of damage: physical, fire, electric, and acid. Once again, I'll ask you to pause the video for a moment and come up with some ideas on how we may do this. Again, you have more than enough knowledge to figure out a solution at this point. Unpause the video when you're ready for the answer. What we'll do is add another parameter to the damage method, a string parameter named damage type. Then we'll utilize the if-else if statement to call the correct animation. Just like before, we'll print a message instead of actually calling an animation. So first, we'll add that string parameter. Next, under where the player is damaged, let's add our if-else if statements. First, we'll say if damage type is equal to physical, and then underneath here, we'll print play physical damage animation. Then, immediately under that, put else if damage type is equal to fire, gd.print play fire damage animation. Now for electricity. Else if damage type is equal to electricity. Sorry, I just had to check and see if I was spelling that right. gd.print play electricity damage animation. And now, since we're only expecting 4 damage types, we can just simply put an else statement to deal with our acid. So then else, which wants to put those curly braces there, but I don't want them since I'm only doing one statement, play acid damage animation. Finally, we need to test. Let's clear out the ready method and start damaging our player. So first we'll do damage, and we'll do 2 damage to him here. And we're going to do fire. Then we're going to do damage, just another 2 for here. And we're going to print acid. So if you remember, fire is our first else if statement, and acid is under the else statement. Save your script, return to Godot, and run the scene to test. Okay, in our output console, we see that the fire damage animation plays, and then the acid damage animation. This is great. It's exactly what we're looking for. What you just saw is a perfectly valid use of the else-if statement, but as we add more and more damage types, that block could get a little difficult to read. Additionally, if we're checking the value of one thing to see if it's equal to several different values, there's a more efficient decision statement we should be using: the switch statement. The syntax of a switch statement is a bit different than what you're used to. You type the word switch, followed by the variable you want to check in parentheses. Then, within curly braces, you type the word case, followed by the value you want to check, then a colon. Basically, you're saying, in the case that the variable is equal to this value. After the colon, type the code you want to execute if the variable is equal to that value. Once you've finished typing the code you want to execute, end with either a return statement, which, if you remember from the last lesson, will exit your method entirely, or break, which is a keyword that will break out of the current code block you're in. Remember, code blocks are determined by curly braces, so these break statements will break you out of the switch statement only. Optionally, you can add a default case at the end of your switch statements cases, which acts as an else statement. Basically, if the variable you're checking isn't equal to any of the values that you have in your case statements, code found in the default block will execute. Again, the default section isn't required and is purely optional. What I'd like you to try and do now is replace the damage type if else if statements with what you just learned about switch statements. Once you've given it a college try, come back for the answer. And here we've converted the damage type block to a switch statement. We've typed switch followed by the damage type variable in parentheses. Then each of our case statements are each of the damage types. Each of the case sections end in break to break us out of the switch once they've executed. In this example, we check for each damage type explicitly, and we use the default block to print an error message. This is actually a better convention because this way it makes it a lot easier to add additional damage types if we want to, and it gives us a handy dandy error message in case we do something wrong, like have a typo in our damage type string. Typos are very common. If you save your script and run your seed in Godot again, you'll see that this works just like our if-else-if block. That's it. Condition statements and decision statements. And we're not talking about in a nutshell either. You're not missing out due to concepts that can't be explained until later. Say for another slightly more confusing way to write switch statements, you got the whole enchilada. That doesn't mean you're getting out of some homework, though. Add an if statement to the damage method that checks if the player is at or below 0 health. If so, call a new method, kill, which prints the statement character is dead. Add a fourth method, change health, that takes an integer argument called delta. Delta can be a positive number if health should go up, or a negative number if health should go down. This method should have the same checks as the heal and damage methods. So the player should never go over max health, and the kill method should be called when the health is less than or equal to 0. Think of it like there's a power-up that can change its state when you touch it. Sometimes it'll damage you, sometimes it'll heal you. That power-up would call this method. So now that you've learned what condition statements are, how to combine those condition statements, and how to branch your code using the if, else, if, and switch decision statements, you're probably starting to see how game logic can fit together. In the next lesson, we're going to start talking about collections with arrays, which are a way to fit multiple values in a single data point. Please make sure to subscribe and hit that bell icon if you're interested so you don't miss that. Until then, take care of yourself. I wish the best to you and yours, and I can't wait to see you again. Have a great one.